Hi everyone, welcome to this video. I'm going to show you today how to do a power analysis using G-Power for a one sample t-test. So of course this will assume that you have installed G-Power first, and I'm going to put the link in the description for G-Power. So here's an example case study here. So in this case study, we aim to determine the sample size required to test whether the mean daily sleep duration of a group of adults significantly differs from the recommended 8 hours per night. Based on prior studies, we expect that the population studied sleeps only 6 hours on average. So my comparison value is 8 hours, and that's the recommended sleep duration. I'm going to use as my expected mean 6 hours, and that's what I expect that will happen in my sample. And I'm going to use an expected standard deviation of 1.5 based on prior studies, an alpha threshold of 0.05, which is standard, of course, in the social sciences. And I want to use here a two-sided test. All right, so I'm going to zoom out a little bit here. Okay, leave a little bit of space for G-Power. So I'm going to click here on the test family. I'm going to click on t-tests. I'm selecting t-tests. Then here, statistical test, I'm going to select means difference from constant, one sample case. Select that. And I'm going to keep the default here a priori. So I'm going to compute required sample size given alpha, power, and fx size. Now, the only thing here is I don't have my estimate of fx size, which will happen in most cases when you're in this situation with a one sample t-test. So we're actually going to calculate that. So I'm going to click on determine. And we have a little bit of an extra toolbox here to determine our fx size statistic based on different characteristics. So here, this is the mean for my comparison value. This is my comparison value, mu0. So it's 8 hours. That's what I expect in the population I'm studying here. So I expect 6 hours of sleep. And this is the expected standard deviation. So we said it was 1.5 hours. 1.5. And that's it. So I can click on calculate. It's going to give me an estimate here for Cohen's d. It's a large fx size here. But I can also click on calculate and transfer to main window. That's going to directly put here the estimate of fx size directly in the window here. So this is pretty convenient. Well, no need to change anything. I'm going to click on close fx size drawer. And next, what I will do is, so this I'm going to keep 0.05. I want a significance level of 0.05. However, I need to change that to a two-tailed test because that's what I wanted to do. You don't have to do that, but that was a part of the instructions here. And I'm going to select also a statistical power of 0.8 for this first question. So the required sample size to achieve a statistical power of 0.8. So I'm going to change that to 0.8. That's it. Click on calculate. And I see that I need a total sample size of 7. That's not, of course, not a lot, but that's because it's a very large fx size here. Second question, what is the observed power for a sample size of 50? All right. So what I want to do now is I want to solve for statistical power. So I'm going to change that part, type of power analysis, to postdoc, compute achieved power. So I'm going to click on that. I don't need to change anything here. The fx size is already, it hasn't been changed. I still want a two-sided test. I still want an alpha threshold of 0.05. However, I want to know of the statistical power with the sample size of 50. It rounds to 1. It's not exactly 1, but it's very, 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 very close to 1. It's a very high statistical power here. In this case, again, that's because I have a very large fx size here. And then the next question is, what fx size can be detected at a power of 0.9? So for this last question, I want to solve for fx size. So what I'm going to do now is I'm going to click on sensitivity, compute required fx size. So again, I want a two-tailed test, an alpha threshold of 0.05, and this time I want a power of 0.9. And again, of course, I have to make an assumption. It was not in the instruction here, but I'm going to keep my sample size of 50 here. And so I want to know with the sample size of 50 and statistical power of 0.9 what fx size I would detect. And you see that here I would detect fx sizes of 0.47, about 0.47, and this is a standardized mean difference, right? So it's how many standard deviations apart my comparison value and the mean in the population that I'm studying are. Right? Yeah. So that's it for this power analysis using G-Power. See you next time.